This conference will now be recorded.
We will start with the project. Okay, so the project will be on Ethernet protocol and Ethernet core verification using System Verilog and UVM. This is a very important project because this is one project which gives you the exposure to the entire flow involved in a project. You see, till now you have learned System Verilog, UVM, individual protocols like AXI, and how to develop the verification IP for the individual protocols is all what you have learned. From in this project, you will be connecting all things. Basically, how to read the specification, how to develop a verification plan, how to develop a test plan, how to list down the functional coverage points, how to develop the test bench architecture, how to develop test bench components, and how to do the register model development and integration, how to integrate the test bench, how to develop sanity test cases, and how to develop functional test cases. All that you will be getting exposure as part of this course. So basically, it's a end-to-end project where you start from the reading specification till you do the coverage analysis and coverage closure. Okay. Uh, okay. When you get into the industry and you work into some industry standard project, this is the kind of work you will be doing. You are expected to do. Sometimes you may not do everything. They may only ask you to do coverage analysis. They may ask you to only do integration of test bench. They may ask you to only do scoreboard implementation. Sometimes they may ask you to only do the test plan. So the work could be one of these things. So the point is what, if you learn entire flow, then there is no doubt, right? I mean, if you know, given a project, if you know the entire flow, you can work on everything. You can work on anything in the project. So with this understanding, let us now start with this project. This project will be learned in two stages. One is learning the protocols. One is the learning the protocol. Second will be, I mean, one thing will be working on protocol, learning of protocol. Second thing we'll be learning on the verification training. We're going to work on MAC Ethernet core verification. Okay. So for 1 or 2 weeks, initial 1 or 2 weeks, we'll only focus on learning the Ethernet protocol. Okay. So as part of that, we'll start off with understanding the communication protocols. We will understand computer networking. We will understand Ethernet standard. We will also understand IEEE networking standards. We will understand OSI model, various things starting from the basics of communication protocol to MAC layer and MAC architecture, everything we'll understand. The MAC stands for Media Access Control. So let's start with, okay. Uh, it is, I think, let's anyway go as per the flow. Okay. Uh, See, Ethernet protocol, Ethernet MAC verification using SV and UVM, entire flow from specification to coverage closure. Uh, see, this design is a complex design. I mean, a medium complex design. Ethernet MAC has a lot of features. See, if you take a simple analogy, how complex is Ethernet MAC is? Traffic controller versus mobile phone, which is complex? Can you tell me whether traffic light control is complex or mobile phone is complex? Which one is complex? Can you tell me? The mobile phone is complex. Why is it complex? It supports a lot of features. Because it supports a lot of features. Uh, okay, it is complex. Traffic light controller has only one feature. Traffic light controller has only one feature. Hence, it is simple. Similarly, router has only one feature. It has no registers, hence no complexity. Whereas Ethernet MAC has 20 plus features. Half duplex is one feature, full duplex is one feature, control frames is one feature, pass frames is one feature, IPG interpacket gap is one feature, buffer descriptors is one feature. I mean, you may think, what is half duplex, what is full duplex, what is control frame? As we go forward, we'll discuss about all these things. But for now, understand that more, if a design has more features, the design complexity is measured in terms of the number of features. Okay. To implement various features, you need a lot of registers. So essentially, you can measure a design complexity based on the number of features, which is also can be measured based on the number of registers present in the design. So more the number of registers in the design, more complex is the design. So that means what? More the number of registers in the design, more will be the more is the complexity. Understood? Any questions so far? Let us start with the fundamentals, basics of this one, communication protocols. As you are aware, there are different peripheral communication protocols are there, like USB, PCI Express, SATA, DDR, HDMI, VGA, SPI. These are all peripheral communication protocols. The question comes with so many protocols. See, do you see Ethernet there with so many protocols? What is the need for a new protocol? What is the new need for a new protocol like Ethernet? Understood the question? With so many protocols existing, what is the need for a new protocol like Ethernet? See, existing protocols are not able to meet the networking specific requirements. See, uh, networking of components, routers, switches, the various LAN ports, these protocols are not meant for that actually. So that is where we need a new protocol called as Ethernet, which is specifically developed for networking of components, networking purpose. Okay. Next, what are the networking protocol requirements? Okay. If you ask me, what is basically requirements of a networking? One is you need LAN. Your protocol should be able to support local area network required different types of packets. Network means what? Required different types of packets, right? All these packets need to be encrypted. I mean, you can understand what is meant by networking and all that. So for this specific requirement, you need Ethernet. You understood the point we are trying to understand is with all the protocols, with so many protocols, why do we still require Ethernet? USB, PCI Express, SATA, these kind of protocols are not meant for creating local area networks. Next, where Ethernet is used, where do we use Ethernet? It is used in network communications. There are different types of networks are there. If you ask me how many types of networks, there are majorly two types of network is there. One is the local area network, LAN. Then other type of network which in turn connects the LANs. See, one network itself is the local area network. The other type of network is the one which connects the LANs. Okay, the networks that connect the LANs. So what does Ethernet provide? Is Ethernet provides a low cost implementation for networking communications. It is ability to secure the data and very high speed communication possible. With Ethernet, a very high speed communication is possible. It can provide speed up to 400 gigabits per second, Now we are talking about even 800 gigabits per second. The latest Ethernet speed we are talking about is 800 gigabits per second. Just to give you a feel of what is 800 gigabits per second, your movie, which is 1 gigabyte, will be downloaded in 2 seconds, 1 or 2 seconds. Working at 800 gigabytes per second, Ethernet at 800 gigabits per second can download a 1 gigabyte movie in less than 1 second. How do you say, how did we say less than 1 second? Simple. 800 gigabits per second is what? 100 gigabytes per second. So 1 gigabyte movie will require 0.01 second to download. Because you can download 100 gigabytes per second. To download 1 gigabyte, you need only 0.01 second. This is the rates we are talking about. Though practically you don't get such a speed, but you will still get somewhere close to that, because there will be some overhead. Because of overhead, you may not get the theoretical maximum, but this is how it works. What is the problem with USB? Now the question comes, whatever Ethernet is doing, why USB is not able to? Okay, why can't we use USB for network communication? The problem is the signal attenuation. See, signal attenuation means signal gets degraded. Uh, in USB, signal gets degraded. USB cable can only be few meters, maximum 2 meters, I believe. Okay. USB can't encrypt the data. USB don't have a concept of data encryption, means you cannot protect the data. So these are the problems with USB. To solve these problems, we have a Ethernet which addresses these kind of requirements also. Next, let us start off with understanding what is meant by computer networking. Okay, what exactly is a computer networking? Tell me. A group of computer systems or any hardware devices connected together is a computer networking. Basically, linked together through communication channel. The devices linked together through communication channel. uh, Basically they facilitate communication and resource sharing. Resource sharing means what? You can share some common memory across multiple devices. All the connected things in the topology will be able to access the same resource. That is what we mean by resource sharing. Okay. We are trying to understand the basics of computer networking. See, these are the two examples you can see. One type of networking, this another type of networking. Any questions till this slide? Okay. First, let's understand the need for a Ethernet standard. I mean, even Ethernet has a standard. Okay, it follows what standard? 802 standard. All Ethernet communication follows IEEE 802 dot standard. First, let's understand why there is a need for such a standard. Okay, do you understand the question? Why do we need a Ethernet standard? If you list down, let's list down few companies which develop networking components. Let's list down few companies which develop networking components. Like companies like, what comes to your mind? Cisco, Juniper Networks, TP-Link, Tejas Networks, Huawei. So these are the various companies that comes to your mind, right? And all the laptop manufacturers. Even a laptop needs some networking components, right? My laptop, can it work without having a Ethernet port? So even my laptop manufacturer becomes a networking component manufacturer, right? So these are the various companies who work into networking component manufacturing. See, they also need networking logic. See, laptop also requires networking logic, right? So any component that has Ethernet port is a networking component. If there is no standard, then what will happen? Every company develops products in their own understanding. Without a standard, what will happen? Cisco will develop as per their own understanding. Juniper will develop as per their own understanding. Tejas will develop as per their own understanding. What will happen? Compatibility issues will arise, right? Because of this, what will happen? Compatibility issues will come. Hence, because what is mean by compatibility? I purchased laptop and I purchased some router. I'm trying to connect both of them. So let's say laptop is manufactured by Lenovo. The router is manufactured by Cisco. If they are not compatible, I cannot connect them, right? Hence, they need a standard which Cisco will follow and even Lenovo will follow. That standard for Ethernet is called as 802 standard. So if we go as we go forward, we'll understand that Ethernet is a complex protocol. It needs to support very high speed, very minimal errors, ability to recover from the errors, ability to encrypt the packet. So it's as a complex protocol, it needs to support so many things. Okay. So this is to support them, we need a standard which defines all these things. So that standard collectively is called as 802 standard. So we will discuss more about this standard as we go forward. Okay. So before we get into Ethernet standard, what exactly is 802 and what all things consist of 802, let's talk a brief about OSI reference model. It is called as OSI reference model. What exactly is OSI reference model? We'll discuss. Can you please read this once? So there are n number of users who use compute network and all are located all over the world. To ensure national and worldwide data communication systems can be developed are compatible to each other. So ISO has developed OSI model. ISO stands for International Organization of Standardization. This is a model for open system communication, also called as OSI model. First of all, let's understand what is OSI. Open system interconnection. What OSI does is, uh, OSI is not just about this. OSI refers to open system interconnection. It is not just for, it defines, it is a set of guidelines. See, OSI reference model is a set of guidelines. Is a set of guidelines that any high-speed protocol can use for the for protocol definition purpose. Let's understand what exactly OSI does. If you just go to internet and search OSI reference model, you will see 7 layers. You will come across these 7 layers. Down you can see physical layer, data layer, network layer, transport layer, session layer, presentation layer, application layer. You will come across 4 layers. What does the OSI reference model tells is, in a simple, there are two things you have to focus on. One is the layer specific to the hardware. One is the layer specific to the software. That means if you buy one PCI Express based device, that hardware, the hardware specific to that is implemented here. You will hear the terms PCI Express drivers, USB drivers, like that. They are all implemented here. Please go through this layer. So simple things, like when people say USB drivers, these are the USB drivers. These USB drivers are working. When we say USB hardware, this kind of will represent the USB hardware. That is how I want you to understand it. So even when you go to PCI Express, upper layers are the PCI Express drivers, the lower layers are the actual PCI Express hardware implemented. So the physical layer of the PCI Express, data link layer of the PCI Express, networking. I mean, I won't call the networking layer. It will be called as a transaction layer. The layer names will differ. Uh, that is why it is called as a reference model. Reference model means it is not a rule that you must follow. It is up to you how you want to understand this and how you want to implement it. So what PCI Express does is, in case of PCI Express, it implements these things. Instead of networking layer, they will call it as transport layer, transaction layer. They will implement these things into hardware. These things they will implement into the software, are drivers, embedded systems. Okay, that is the basic concept of OSI reference model. You don't need to know more than that. Okay. uh, Next, I have already told you need for IEEE networking standards. See, like I told you, laptop is manufactured by one company. Okay, I think this we have to study. Let's keep it. Let's study need for networking standards. Networking, as I told you, different components are developed by different companies. So companies developing networking hardware needs to follow a set of guidelines so that those devices are compatible with other devices in the network. Uh, so that standard is called as ISO networking standards. So that comes under IEEE 802. These are the set of LAN technical standards: 802.1, 802.2, 802.3 up to 802.24. Tell me how many numbers are there totally? So IEEE 802 has totally 24 standards below it. It consists of totally 24 standards. Out of them, the LAN connection you use, let's say you connect one laptop to another laptop through a LAN cable. That standard is called as 802.3 standard. Like wired LAN works on 802. Means when you send a packet from here to here, when you get a packet from here to here, it is working as per this standard rules. Means one laptop connected to another laptop through the LAN cable, the communication is happening through 802.3 standard communication. Then wireless LAN is happening through, like, see, wireless, right? My laptop is now connected to Ethernet, to the router, Wi-Fi router through wireless, right? It is using 802.11 standard. See, there are two standards here itself, you can see. Then I get a broadband connection. See, my internet service provider can give me broadband connection. It works on 802.7 standard. So these are the various standards that are available in the 802. Now you may ask, what about other numbers like dot 1, dot 2, dot 4, dot 5, dot 6? Many of them are redundant actually. See, currently these are the only active standard: 1, 3, 11, 15, and 18. See, 802.1, 802.3, 802.11, dot 15, and dot 18, and dot 18 are the only active standards. Other standards are not used. Kind of, you can say, redundant. Okay, have you got a basic idea of what is 802? All the Ethernet related, networking related standards are kept under 802. In that, you have various standards, like Ethernet comes under 802.3. See, 802 doesn't mean Ethernet. 802 refers to networking standards. Okay, under networking, you can do wired LAN networking, wireless LAN networking, broadband LAN networking, WiMAX networking. There are different types of networking. So they are this 802 dot standard, which this we have discussed. Okay, let us now quickly talk about this one, OSI reference model. I have told you what is OSI reference model. All networking standards are developed using a common reference model. OSI stands for Open Systems Interconnection. What does OSI does is it divides any networking device implementation into two aspects. One is the hardware, one is the software. The lower part, as you can see, constitutes the hardware layers. Upper part constitutes the software layers. Okay. Every device is implemented in the same manner. Any networking communication, they will implement into two parts. Hardware will consist of network, data link, and physical layer. Software will consist of application, presentation, session, and transport layer. Okay. Imagine now, how do you understand this layer 6? Imagine a phone without a OS. Phone without a OS. Will it work? Can you think of a phone without a OS and drivers? Can we imagine such a device? No, right? You cannot imagine. So the phone has an hardware that you can think of lower layers. I'm just giving an analogy, okay? It's just an analogy. Don't take literally this analogy. The hardware becomes the lower layers. The drivers, OS, and application becomes the upper layers. It's just an analogy. Okay. Even phone has a modem. Even that modem will have these layers actually. Let's say, as a if I'm developing, I'm manufacturing a router, so I need to ask which. So actually, see here, what happens is I'm developing a router, so I have to decide what am I. Okay, I'm developing a router. I need to ask, am I developing am I a, uh, OEM, original equipment manufacturer? Am I a OEM, or am I a driver? Am I a application developer? The OEM stands for original equipment manufacturer. Means the companies who develop these parts are the OEMs, original equipment manufacturers. Then the companies who buy this hardware and develop applications will fall into this category. See, who does the OEM work? OEM work is to work on the hardware layer. They actually manufacture the hardware. Did you understood? Clear, right? Next. Uh, Even when I'm developing a router, now, wait, wait. How about now? Can you hear me? Okay. So I was telling you that, let's say we are working on a uh, understanding standards. I mean, which standard to understanding? 802 dot standards. So as a manufacturer, as a device manufacturer, I need to know what is that I'm developing. Accordingly, I have to choose a standard. If I'm developing a wired router, then I have to go with 802.3 standard. If I'm developing a wireless router, I have to go with 802.11 standard. And also understand that router just as a hardware, just as a hardware will not function. It we need we need to develop both hardware and the corresponding drivers. Next, uh, let's understand this concept of application layer OSI reference model through a simple analogy. I don't know how much simple I can make it, but let's understand it through one simple analogy. Uh, okay, a simple analogy we'll take is a food delivery service. We'll take a simple analogy of food delivery service. User places an order and gets item. So we are talking of an example of food delivery service. Let's say user places an order and gets the item. At top level, two entities are involved. Two people are involved. Okay. One is the customer. This is the node that is requesting the data, placing the request. Node which is placing the request. Placing the request.
Second is what? The restaurant, the node which is servicing the request. See, one node is placing the request, other node which is servicing the request. This service requires application at customer node, presentation of the order. See, this service requires application. See, user needs one application, right? Swiggy or Zomato, one of the application you require. So at the customer node. So that I would call it as the application that he is installing. I will call it as an application layer. And that application will give you the presentation, right? How do you choose the things? How do you present? I mean, the presentation of the information to you. Okay. Then when you place an order, in the Swiggy, okay, a session gets created on the platform, Swiggy platform. As you can see, when you place the order, a session gets created, okay, which exists till order is closed. That session exists till order is closed. Then once you have done all these things, once you have created a session, the request will go to restaurant. See, as soon as you open the application, will the request go to restaurant? No, right? Only when you start a session. Once you start a session, the request or the order goes to the restaurant, and the order is prepared. So this is who prepares the order? The physical people who are present in the restaurant. So this work is all happening on the software. This work is happening on the hardware level. See, some part of the activity happens at the software level, some part of the activity happens at the hardware level. Even when you collect the food, see, order is collected, delivery boy vehicle is involved. This is where lower layers comes into picture. So this is where lower layers comes into picture in both the things. Then customer collects the order, collects the items, session is closed, and application at the restaurant closes the order. So I'm just trying to give you an analogy how you start at application layer, then how you goes to presentation layer, how the session gets created, how that gets further communicated to lower layers. We are just trying to understand this through one simple analogy. Okay, so if you understand it, uh, what makes this Swiggy and Zomato complex is thousands of people placing thousands of orders from thousands of restaurants. They understand the complexity. There are thousands of people placing thousands of orders from thousands of restaurants. All order tracking done using different sessions. All orders tracking is done using different sessions, using session ID. See, it is possible that you could create multiple sessions. Session layer creates different sessions. Each thing is tracked through a different session ID. Okay, now the question comes, what medium to use? See, in this food delivery service, you could use different medium, right? Delivery boys using a bike, using a car, using a drone. See, bike could be like a wired LAN. I'm just giving a simple analogy. Drone could be a wireless LAN. Okay, so my point is the connections you do at the physical level could be wired physical connection, could be a wireless connection. So uh, just to make them independent, we have developed this whole implementation into different layers. What can go wrong in this whole networking? What can go wrong? Application doesn't work, order doesn't get placed, so on. So there are different things that can go wrong. So that is where they decide whether the issue is at the hardware level, issue is at the software level. So this is a very brief about Ethernet standard. So we will actually, I have some work, I have to go out on some work. So we will continue with the session from the next session. I mean, ideally, I wanted to cover some of these topics. We'll talk more about these topics in the next session. I want you to just go through OSI reference model. I want you to do little homework regarding Ethernet protocol. Okay, before the